Hello and welcome to this pre-recorded webinar where I'm going to give you an overview on the BMW F-Series Tuning Suite from EcuTek. First, a quick rundown of what I'm going to cover today, and then we'll get straight on into it. We'll run through what the product consists of, the models it supports, the tuning results you can expect to see, the benefits for the tuner and why you should choose EcuTek, benefits for the end user and why they should come to you to have their car tuned with EcuTek, some of the tuning basics for BMW F-Series and the maps to support it, live data and logging functions, quickly go through the workflow required to tune a car, then we're going to go through a complete tuning process from end to end, cover the ECU Connect app and the support for BMW, quickly go through the product roadmap for 2019, and a brief summary of answers to frequently asked questions. So let's get started. So what we have is a complete all-in-one tuning solution for the F-Series fitted with the N55 and S55 six-cylinder engines, combined with the Bosch MEVD 17.2.6 and MEVD 17.2.G ECUs from 2011 onwards. The tool features ECU unlocking, ROM editing, ECU programming, log creation, log analysis and diagnostic features in one tool. We've given you clearly defined maps for tuning the cars, comprehensive 2D and 3D map editing tools. We support remote or e-tuning. A comprehensive library of stock ROMs is available for automatic download when you install the software. You can import your existing tuned ROMs by importing the files directly or reading them from the ECU. We can compare and copy maps between ROMs. And obviously, we have a robust programming process with built-in ECU recovery should programming be interrupted. The tuning suite supports a wide range of cars from the worldwide market, ranging from the M135i at the smaller end up to the barge-like 640. It also includes fringe models like the GT and X-Drive 35i, and obviously the halo cars such as the M2, M3 and M4 with the S55 twin-turbo engine. On our 435i development car, we found excellent gains even in stock form. 80 horsepower and 100 foot-pounds of torque just from ECU tuning, with peak power increasing to 386 horsepower from the stock 306. Peak torque's up to a very respectable 400 foot-pounds, and we're still only running a moderate 1.1 bar of boost at peak. Typically you'll find that the same peak figures can be achieved on most of the variants, so on those cars that start off with more power from the factory, we'll have a smaller gain. You can start tuning your first BMW F-Series within an hour of purchasing the software. If you're an existing dealer and you've already got one of our green hardware cables, you can just buy it in the web store, download the software, download the ROMs, and get going. It really is that easy. Existing EcuTek tuners will be familiar with our all-in-one tuning approach. It's a single application that handles ROM editing, programming, logging, and OBD tools. So there's no binary file conversions, there's no hunting around with a hex editor. We can import common ECU formats for BMW from other tools. We can read the calibration data directly out of the ECU. When it goes to program, there's no messing around with checksums, that's all handled automatically. And if you're tuning the car in person, things like map tracing can make your life a lot easier. As an EcuTek tuner, there's comprehensive email and telephone support available. As with all of our software, we provide all the stock ROMs that you need. They're stored locally and updated automatically. Tuning can be carried out 100% offline. You don't need internet access to actually tune the car, just to receive the updates. If you're an existing EcuTek tuner, BMW F-Series is the ideal platform to start a remote tuning business. ROM files are encrypted and can be locked to a VIN or hardware license key. We update ECU security to prevent overprogramming or reading via OBD, and the programming sequence is also encrypted to prevent ROMs from being sniffed over the CAN bus during programming. If you or your customer are lucky enough to have one, then investing in EcuTek could be a great next step. They're a really good car out of the box, but with mild upgrades, they become excellent. Our M235R development car is such a good car with just a stage 1 upgrade. If you add to that some basic hardware updates, 420 horsepower isn't out of reach, and then the lighter weight 235i and 135i really compete with the M cars as they come from the factory. The already excellent M cars can be pushed to another level with just a stage 1 upgrade and even bigger improvements when you add some more hardware. Using EcuTek, you can program a tuned ROM without invoking any tampered ETCs or changing the CVN. ECU Connect adds logging and basic diagnostic tools that can be used to validate the quality of your tune, allowing end users to build a relationship with their tuner by sending logs back and getting further map updates. As EcuTek adds race-ROM special features to its products, end users can benefit by getting updates through the lifetime of their car, and furthermore, the ECU can be completely returned to stock with minimal fuss. The BMW ECU has a complex torque control strategy around which most of the other strategies are hung. Even things like the variable valve timing are driven by torque when you drill down. In this modern world, I'd really encourage any tuner that wants to do great work to embrace some of the modern ECU technologies. It's time to move on from thinking about only wide open throttle boost, a near fixed AFR and dumb ignition control. Let me take you through some of these maps in the initial release of ProECU. So you can see that we've got ignition based timing for a number of different conditions. We've got some minimum ignition maps, and there are other compensations not shown on the screenshot on the right. Fueling, we've got basic AFR target and target compensation maps. The boost control is relatively easy to get your head around. There are some modelling based maps that you can use to influence how the boost is controlled to hit the target, but the target is largely driven by torque. Of course, there's everyone's favourite, the burble maps for pops and bangs. There's a good selection of knock detection and knock control maps. Cams are adjustable for both timing on the inlet and exhaust and lift on the inlet. Torque control is relatively straightforward on the BMW. There are a few maps that set the base demand, and then again the same concept of having compensations or adjustments to that base level. There's a standard selection of rev limits and speed limits, and we've also got some sensor scaling, and lastly a comprehensive table of DTC codes that can be switched on or off. As I mentioned before, as part of the all-in-one nature of this tuning solution, data logging and analysis is included. There are hundreds of parameters available, but obviously not all of the parameters are useful for tuning. So we've selected 40 default parameters as standard, and we typically get about 19, 20, 21 Hz of logging speed with that. You can data log using ProECU and a laptop, or using an iOS or Android device in our ECU Connect app. If you're using the app, it's very easy for end users to log the car, email the log straight back to the tuner without going anywhere. The tuner or the end user can analyse data logs using ProECU, and all data logs are saved in a basic CSV format, so they can be edited with a spreadsheet or viewed in other tools such as Megalog Viewer. You can also stitch multiple log files together using the Merge Log File tool from within ProECU. Once you do get some data logs, you can view them using ProECU as table data, 2D time graphs, XY plots, 3D point fields, and overlaid onto an existing map. We've also recently introduced tools that allow you to match a ROM and a log, so you can ensure that the data log a customer sends to a remote tuner is in fact generated with the tuned ROM that they sent out. We don't think that tuners should be IT experts. We don't require them to be ECU reverse engineers or have a depth of IT skills just to make an engine run as they want to. Now I know this looks like a long and involved process that I've outlined for a traditional workflow, but there are a surprising number of tuners that still use this, using multiple tools to get to the point where the car is tuned with confidence. Now if you've already invested in a wide range of tools and you're from the file tuning sector and you're comfortable with this longhand approach, there's no denying that it can get the job done. Now, I know that there are other tools out there, but none that I think offer the level of integration that we're providing. And I know that there are tuners out there still using this long form workflow and looking to consolidate it into a streamlined process like the one EcuTek provides. I won't bore you with all the details of the hardware, but if you're doing it this way or you recognise a lot of the steps, then there probably is a better way for you. If you're tuning with EcuTek, all you need to do is connect to the car, get the details of the stock ROM, unlock the car, and then if you've got your standard tuned ROM, you can copy the maps from your reference ROM into the correct ROM for the car, program it in, use that as the base for initial testing, road or dyno test, check the logs, ensure that everything's okay, and at this point you might be finished. Otherwise, make some further changes, program it back in, and you're done. Now I'm going to take you through the entire process of taking a car from completely stock, unlocking it, creating a tuned ROM file from scratch, program it, test it, look at the logs, compare to the stock ROM, and then ultimately we're also going to return the ECU to stock. So I'm sat on our M235i development car, and I'm going to quickly run you through the ECU unlock process. I'll start by opening ProECU, turning the ignition on, Tools, Detect Vehicle, then we're going to go ECU Unlock Tool, click OK or press Enter, click on Query ECU, see the various elements of the ECU contents displayed, then click on Load ROM. It's pre-filled in the details of the correct factory stock ROM file here, so we can just click on Open, Unlock ECU. It's backing up the vehicle coding. You can hear that the car is complaining that it's lost communications with the ECU. Also see here that I've consumed 300 points from my hardware key. So erase the bootloader, reflashing the bootloader, and that's going to run through till the process is complete. So now that the ECU is unlocked and the DTCs have been cleared, as per the instructions here, please cycle the ignition. So ignition off. So now that we've unlocked the ECU, I'm going to do a brief dyno test of the stock calibration. So I open the stock ROM, in this case from the recent ROMs pull down. I'm sat in the car with the engine running already, so we can click on the Live Data tab, Map Access. Now we can see the live data being returned to ProECU. I'm going to click on Log to File, which is going to create our CSV log file. Now I'm going to switch over to our dyno PC via remote desktop. Okay, we're getting the car going. Switch to manual mode. Turn the traction control off.
Nice low RPM.
To sport mode.
Oodles of torque low down. It's not particularly happy on the dyno.
We have to start nice low RPM. So we're in an auto test mode. I'm going to roll on the throttle. Still pretty stable. So now I'm going to start the test and go full throttle. There we go. Let's go back to ProECU, stop logging, open the last log file. Here we can click on time graphs. You can see the dyno pull in the middle of the run there, nice and clearly. We uncheck all of the parameters in the log. Then we can look at some of note. So Excel, pedal, boost pressure, target boost pressure. In this case, boost means pressure before the throttle. So lambda values, target lambda values. Look at mass airflow and manifold pressure. Zoom in. Look at some of these data points. So we can see peak boost here through the mid-range, 1.657 bar. You can look at the boost very slightly different due to the pressure drop across the throttle. You can look at lambda actual 0.88, target 0.878, very close. That all seems to be working nicely. Close that. The car's had a chance to run after the pull. Switch the ignition off, turn off map access, and that's the first half done. Let's have a quick look at the dyno results. There we go. Estimated horsepower, in this case at the flywheel or crank, 328 horsepower, 328 foot-pounds of torque. That looks fine. Now that we've unlocked the ECU, we're going to create a basic tuned ROM file to program back into it. So I'm going to open ProECU, and then we go to File, Open ROM File, scroll down, choose the correct ROM, click on Open. See the map tree shown here on the left. We can increase the size of that. We can go to View, increase font size, or we can use the hotkey Control-Alt-I, or we can hold down the Control button, use the scroll up wheel of the mouse. So I'm going to expand maps by function, go to Torque Control, we'll open Base, scroll down a bit, Max Torque Limits. Increase the size of this window so we can read all the map names. So the BMW ECU uses these base and max values as the basis for all of its torque target calculations. So we'll open Torque Max for AT. This car has the 8-speed automatic transmission. Select all the output values. I'm going to use the Control P for percentage hotkey. Enter 120. And you can see that it's scaled all of those values up by 20%. I'm going to save that. Then we'll close it. Then we're going to do something similar for the torque max per gear, mode 1 and mode 2. I'm not going to go into details of what mode 1 and mode 2 are, but there are two slightly different modes which are determined by some other maps. But for the most part we can just make the same changes to both the maps. They're identical in the stock ECU. So I'm going to use Control P hotkey, 120, OK. Now we're going to horizontally interpolate across the map. So select the region. Actually we'll go from here and use Control H, and then you can use the hotkey Control S to save. Before we close it, I'm going to copy the entire map to clipboard, which we can do from the Edit menu, or use these hotkeys here, and then paste it into here. For this I'm going to use the hotkey Control-Alt-V, and then again Control S, and then close both maps, Control Q, Control Q. So that's modified our base torque targets, which set the basis for the torque calculation, and generally they represent 100% of the desired torque. And we can open the Accel progression maps here, which I'm not going to change this time, but let's have a quick look. And you can see that you've got comfort mode, which is kind of your normal mode as set on the center console of the car, and then you've got an eco mode and the sport mode, and you can see the differences in the shapes. And this is how the different driver feel is created for each of those modes. But for the moment we're just going to leave those standard. However, for a decent quality tune I would recommend that these are edited, and we're going to cover those separately in another video. So we've increased the torque, but it might be limited elsewhere by the ECU, especially in terms of airflow or load. We're we go to load control, you can see we've got load limit under knock correction, load limit knock correction in super knock. Open this first one, just expand this a little bit so you can see the whole axis title. And what you can see is that this x-axis here, which goes from minimum of -13 up to only -3, it says total knock limit adjustment. It's not knock control retard per se, but the total amount of change from the base value, and that includes temperature compensations, knock control, load limit compensations. Typically when everything's running well, we're going to be up here in this -3. Even if the total knock limit adjustment is perhaps 0, this is where we'll be on the map. And you can see that these are load limits, and the units here are percentage of cylinder fill. So we're just going to increase these by the same 20% that we added to our torque. Not Control A, we'll do Control P, 120%, Control S, Control Q. We've got a similar table with the super knock suffix. We'll have a look at that. And you see that that's quite a different shape. And if the ECU determines that it's in a super knock situation, I'll explain a bit more on that later, you can see that it's going to keep a low load limit, especially at low RPM. So the super knock is a BMW term, very similar to the low speed pre-ignition, those kind of phenomenon, but in terms of what the ECU can determine, uses a separate knock threshold and a separate knock window from the main knock control. If those conditions are met, it determines that it's in a super knock condition where it can do additional limitation. So you can see here particularly low load limits at low RPM. Then we're going to raise these higher limits, and maybe we'll just go 110%. But actually I'm thinking we'll be a bit more conservative. And we'll select this area here, do Control Z. That returns it to the original values. Then we're going to interpolate out to where we've got this minimal correction using Control H again. So you can see the highlighted cells, just a small portion of this map. We leave the low RPM load limits in place, where some low speed pre-ignition could potentially do more damage to the engine. So I'm going to save that. Control S, Control Q. Then I'm going to go back into some maps in the torque control category. We've got the turbo pressure ratio limit, which may seem not very torque-like, but it all feeds into the same torque strategy. So you can see it. This is the pressure ratio, so the ratio of the pressure on the input versus the pressure on the output of the turbo. Typically if you were running, say like we have here, 2.4, that would be roughly equivalent to 1.4 bar of boost at sea level. So I'm just going to add a small amount to this, 0.2. Click on OK, Control S, Control Q. Those numbers there, they ultimately get turned into both a load limit and a torque limit. We'll also look at this max load factor, which in simple terms is a relative VE number used as a limit for calculating torque limits, another stage in the overall torque calculation. Now depending on what changes you make to your other airflow and load limits, you might not need to change these, but I'm going to do something that's fairly typical. We're going to fill those, so I'm going to go Control F this time, just fill them with 99. Control S, Control Q. So now we've raised some torque targets, some load limits, some airflow stroke load limits. We're going to make some brief changes to the fueling. Go to the fueling category, fuel target bank 1. There is only one bank on this engine. But the same map structure exists for the S55 with 2 banks. And we're going to make a very, very subtle change here. And what I'm going to do is copy these values in, say here, Control copy, and I'm going to paste across there. You notice there's a different size. We do Control V, we can then stretch See, now we've got the same value right across. I'm not necessarily recommending this is the ideal change to make to this car, but I know from experience that it will be relatively safe for the purposes of a test. Save that, close that. We go to ignition timing, base, and you can see we've split the ignition timing maps into a number of different sort of subcategories by their title. The one that we're really interested in is ignition base timing warm path 1. I don't want to go into too much detail about what path 1, path 2 and path 3 are, but essentially they're different pathways through the code for certain quite specific conditions. And you'll see those crop up for a number of different strategies, and for each strategy, each path number is specific to that strategy. So path 1 for ignition is not necessarily the same one as path 1 for variable valve timing. Now, based purely on some experience I have with this car, and the fact that we're running this car on super unleaded, I'm going to add 1 degree of timing. Control A, 1, enter. You can see the effect of that over here. Save that and quit. We can also go back to the fueling. There's another fuel map we might be interested in, which is the fuel target in supernock. It's the same supernock condition that we saw for the load limit. And you can see here that if the ECU does detect supernock, it richens up this low RPM area considerably, and you can also see that it has a slightly richer target at the higher end, although supernock or low speed pre-ignition, as the name suggests, tends to be a phenomenon most affecting the low speed running of the engine, which is why we see this here. Now, I'm not going to lean this out. I don't think there's anything to be gained by adjusting this. We shouldn't really be in supernock, and if we are, we certainly don't want to reduce the ECU's capability of mitigating that knock. So we'll close that. So now I'm going to save a copy of this ROM file. So go File, Save ROM File As. We're just going to put a little suffix in the name. We'll call it Webinar 1-ENC. With that ROM file saved, we're ready to go back to the dyno, program the car, and test to see what our results are. So we need to go to Tools, Program an Engine ECU, and click on Program ECU. ProECU prepares the ECU ready for programming. And we'll rejoin this towards the end. And the ECU program is complete. Click on OK. Close the programming window and cycle the ignition off. Back on. Let's see if we can start the car. There we go. ECU programmed. So I've restarted the fans for the dyno. Have the engine running. Click on Live Data. Zoom in a bit. Click on Map Access. You can see that we've got live data returned to ProECU. Now I'm going to click on Log to File again. Go back to the dyno. Prepare to do another run exactly the same way.
So there we go, some minor adjustments. We've managed to make a small gain in the power and a significant gain in the torque.
So now that we've finished on the dyno, let's do a quick comparison of the results. I've combined the two dyno graphs into one, so we'll flip over to the remote desktop of the dyno PC. We can see we've got a nice healthy gain of torque through the mid-range here. Ignore this difference at the low end. This is mostly down to being able to get on the power a bit sooner after the tyres had warmed up on the dyno. We've got a 20 horsepower gain at the peak, and all in all, not a bad improvement for 5 minutes of map editing. Now I know this doesn't represent the ultimate improvement that we would be looking for, but it's just a representative example to show you how this can be done. So we've had a brief look at the dyno results from the stock ROM and the modified ROM. Let's have a look at the data logs too. We can open up an Explorer window, go to Map Access Logs in the EcuTek folder, and we'll open up this log here for the modified ROM. We can drag that straight to the ProECU window to open it. As before, we can go to time graphs. You can see we did 2 runs. Let's go to the second run on the dyno. You can find that easily. So we'll uncheck all of these parameters, look at axle position, engine speed, and we'll start with some fueling checks. We'll look at the trims and lambda and target. So you can see that the short-term trim is very tight, plus or minus about 2%. Disappears off a little bit at the end where it starts to richen up and the ECU pulls it back in, but very impressive for an OEM ECU. So lambda actual 0.85, yep. Okay, we've satisfied ourselves that the trims are okay, the lambda's okay. Let's have a look at fuel rail pressure, nice and flat. And we can look at the throttle pedal. We can look at the throttle actual. And here we can see that there is something that requires our attention. As the dyno pull starts and the engine RPM starts to rise, you can see it starts to close the throttle here. And that is almost certainly a result of some load limit coming into play. So we can look at engine load desired and relative cylinder fill. And you can see here that just at that point the relative cylinder fill is rising slowly and will cross the engine load desired. So the ECU responds by closing the throttle to modulate the load. It does this automatically. But ideally what we want to do is manipulate either our torque targets or the resulting load targets or direct load limits to prevent this from happening. We can look at the actual boost pressure used to maintain this load, and here we can see 1.87 bar absolute, so 0.87 bar relative. 0.9, there we go. So not very much boost still, which is why we've only got 350 horsepower or so compared to the 380 that is readily possible on the stage 1 modified ROM. So let's go to custom 2D graphing. Just tidy this up a little bit, and we can have a quick look at the wastegate duty. Still nice and manageable. Some headroom there. Something of interest, we've got no knock conditions detected there. Let's have a look at engine load desired versus engine relative cylinder fill, and then bring the throttle up. And let's make this versus time. And so yeah, you can see here as the desired load falls away a little bit, it's here that the throttle interacts. And again, any time that the two meet, you see this quite sudden closure of the throttle, and then as the actual drops away and falls away below the target, the throttle is very, very slow to come back in. Still not a bad job, but that's something that we'd want to address if we were tuning this car for a customer. Now what we want to do is, that's all well and good, but we can quickly overlay these results with the log of the stock ROM. So let's load, drag our modified log, stock log, merge the two, and we'll create a merge 235i, close that, and let's have a look at this log now. We can drag it the same way as we did before. Let's close that. Look at time graphs, and here we go. Here's our two pulls from the modified ROM, and here's the pull we did earlier with the stock ROM. Now if we zoom in here, go to custom 2D graphing again, we can actually see the change in mass airflow. Let's have a look at boost pressure. So you can see the modified boost pressure up here and the stock down there. We can do the same with torque actual. Torque desired for load. So again, it's a moderate increase, which is all we're after in this demonstration. That concludes this brief look at these data, but we'll look again in much more detail in our Stage 1 tuned ROM walkthrough coming soon. Having been through the tuning process, I'm going to return the ECU to stock. The ignition is off at the moment, so now I'm going to turn the ignition on in the car, go to Tools, Detect Vehicle. We're going to go to the ECU Unlock tool. Click on Query ECU. It gives us information on the ROM file that's in the ECU. So now we're going to load the stock ROM. Since it's already determined which is the stock ROM, it's pre-filled that for us in this dialog box. We just click on Open. It's given us some information about the changes that it will do to the bootloader to unlock the ECU, if that's what we want to do. It tells us that unlocking this ECU will consume 300 flash points, but that putting the ECU back to stock is free of charge, and that's what we want to do now. So we just click on Back to Stock. You can see it's backing up the vehicle coding to put back in the ECU later. Okay, now the process has begun properly. It tells us that the ECU contains an EcuTek bootloader, which it's going to erase. Now it's going to start reflashing the stock contents of the ECU, beginning with the bootloader. It's cleared the DTCs. It says ECU relock complete. Please cycle the ignition. So that's what I'm going to do on the car. Ignition off. Close that. Ignition on. Let's try and start the car just to make sure. I've mentioned it a few times already, but I'll quickly cover ECU Connect, which is our companion app for tuners and car owners. It's available for free on the App Store and Google Play. I'd encourage you to give it a go. You can download it. There's sample data stored in the app, so you can have a play with setting up gauges, looking at the data logging, and the other demo modes will give you a flavour of what's to come for BMW. The app requires an EcuTek proprietary vehicle interface that uses our own Bluetooth hardware. This screenshot is just there to give you a flavour, but it gives you data logging facilities with all the data log parameters that are available in the laptop software. There's dashboards that you can see on the right, where you can add your own gauges, bar graphs, line graphs, status indicators. You can set up alarms, change the thresholds. It will read and clear the DTCs. There's a basic performance analyzer, which is quite good for comparing your results. Surprisingly accurate and informative. Depending on where you are, the OBD readiness tool can be quite useful. And finally, there's a map of all the EcuTek dealers, should you need one. As we add race-ROM features to the BMW, with things like map switching, flex fuel, adjustable launch control, rolling launch, we'll typically add controls for those into the ECU Connect app. So on something like GTR, which is one of our more mature programs, we can adjust launch control RPM, boost levels, map switch mode, and we can even set up custom controls to adjust anything that's configurable within the ECU within reason. So I just wanted to go over our product roadmap for 2019 on the BMW platform. Typically when EcuTek first releases a product, it's reasonably basic, and then over the period of the first year we add increasing amounts of functionality. So in the first quarter this year, we're looking to add the S55 twin-turbo platform, which is obviously the M2 competition and the M3 and M4. There'll be more and more map updates, so adding a more comprehensive spread of tuning maps to the product, and then continuing support for adding more and more ROMs to cover more and more models. Along the way, we'll also be hoping to take feedback from our dealers and end users to improve the overall user experience and usability of the software. Starting in Q2, we'll be looking at our race-ROM feature set, so that's going to be on-the-fly map switching, not stop, reflash the ECU, change the map. Live map switching, typically we enable map switching either from the ECU Connect app or via things like cruise control buttons. We're also going to add comprehensive flex fuel support with input from a content sensor, so not just fixed ethanol content values with different maps, but a fully variable system using an ethanol content sensor that we hope to hook in via CAN bus, which means we do away with any restrictions from not having any spare inputs on the ECU. We're going to have DCT transmission programming, not tuning initially, but the ability to program a range of different DCT ROMs. And we'll also start to add some custom live data parameters to really expose what's going on deep inside the ECU. Now obviously I know there's many more things that we could do, and we've had lots and lots of feature requests or model requests, so we're certainly considering things like rolling launch, and we'll also be looking at proper tuning and logging of the transmission, similar to what we offer on the GTR platform. Now you can see the list of engines up there that we've obviously had demand for, and as time goes on we'll evaluate those on a case-by-case basis. We're near the end now, so I just want to cover some questions and answers. I'm not going to read through them all, but I will encourage you to pause the video here if you want to do that yourself. It's a lot of the questions that we've had asked at the SEMA trade show and from general inquiries, and also the questions that were asked in the live webinar before Christmas. Thank you for watching. We're fully committed to making BMW outstanding in 2019. Give this video a thumbs up if you liked it, and subscribe to our YouTube channel to get more how-to videos on BMW and all the other tuning platforms that we support.